Hello and welcome to QPCR Academy. In this video, I'll walk you step by step through setting up a gene expression QPCR experiment using a relative quantification approach with probe-based assays. The workflow is demonstrated in QuantStudio Design and Analysis Software version 2.6.0. In this tutorial, I'll focus purely on setting up the experiment in the software. I won't be covering wet lab preparation or biological interpretation. I'm using the QuantStudio 5 instrument as an example. However, the same workflow can be easily adapted to other QuantStudio instrument series, such as QuantStudio 6 and 7 Flex, or QuantStudio Pro, as long as they use Design and Analysis Software version 2.6.0. Just a quick note before we begin. This tutorial is for educational purposes only. I'm using example settings to demonstrate the workflow, and QPCR Academy is not affiliated with the instrument or reagent manufacturers shown. Let's get started. To start, a quick word about the software itself. QuantStudio Design and Analysis Software is a desktop application that can be installed on a computer connected directly to the instrument or used as a standalone workstation. It's used both for setting up QPCR experiments and later on for analyzing the data once the run is complete. The same software is used across the QuantStudio QPCR instrument family. Start by double-clicking the QuantStudio Design and Analysis Software icon on your desktop. Let's now move into the step-by-step setup. Because this is a gene expression experiment, our goal is to compare expression levels between samples rather than determine absolute copy numbers. That's why we're using a relative quantification approach. Once the software opens, you will see the main screen with three primary options: Set up plate, View data, and Manage instruments. To create a new experiment, select Setup plate. On the left-hand side, you'll see a guided menu that walks you through the initial setup steps. First, select the instrument you are working with. The software displays the full QuantStudio instrument family, from QuantStudio 1 through QuantStudio 7 Pro, which represents the current QuantStudio platforms available on the market. In this example, we will use QuantStudio 5. Next, choose the block type. Available options include 96 well plates with 0.1 milliliter or 0.2 milliliter wells, 384 well plates, and TACMAN array cards. For this example, we will use a 96 well, 0.1 milliliter block. Please note that the QuantStudio 5 instrument supports only one installed block type. Next, select the run mode. You can choose between fast and standard modes. This choice depends primarily on the block type and the chemistry you are using, specifically the master mix. For this example, we will use fast mode. Finally, select the analysis type. Here we choose relative quantification, which filters the available experiment templates. You will now see two template options, CyberGreen and TACMAN assays. For this demonstration, we will choose TACMAN-based comparative CT, which is the relative quantification method that can be used for gene expression analysis. To open the template, simply click on the template icon. Alternatively, if you want to open it in a separate window, click the three dots in the top right corner of the icon. For now, we'll open it directly. The experiment template opens with the initial filters already applied. At the top of the screen, you will see three tabs: Run Method, Plate Setup, and Run Summary, which you can switch between at any time. We begin with the Run Method tab. Below the top bar, you can see the experiment information carried over from the previous screen: the selected instrument, block type, run mode, and experiment type. This is a good moment to double-check that all filters were applied correctly. If anything needs to be corrected, you can return to the plate gallery and adjust the settings. Now, let's focus on the run method. The first parameter to set is the reaction volume. By default, this is set to 20 microliters. Always make sure this volume matches your master mix protocol and block type. The heated cover temperature is set to 105 degrees Celsius by default, and in most cases, there is no need to change it. Next, you see the thermal protocol. The displayed protocol is a default template, but it can be fully adjusted to match your master mix recommendations. Here, you can see an initial hold stage, followed by a two-step PCR stage. All parameters are editable. You can modify temperatures, times, or ramp rates by clicking directly on a value and entering a new one. For example, you could change the temperature to 92 degrees, or adjust the time to 0.5 seconds. To add an additional step, hover your mouse over an existing step until the plus and minus icons appear. Click the plus icon to add a step either before or after the selected step. To remove a step, click the minus icon. You can also add or remove entire stages, such as adding a melt curve stage. Hover over the stage bar until the plus icon appears, then click to add a new stage. To remove a stage, click the minus icon. One of the most important elements of the thermal protocol is the data collection point, indicated by the camera icons. The active data collection point is shown with a solid camera icon, while inactive points appear faded. Make sure data collection is enabled at the correct step of the PCR cycle. If data collection is switched off, the run will not produce amplification data, and you will have nothing to analyze. If you attempt to proceed with data collection disabled, the software will display a warning message confirming that no amplification data will be collected. This is a critical setting to verify. In some specialized protocols, data collection may be enabled at multiple steps, but the default setup shown here is the most commonly used configuration. Each step also includes advanced protocol settings. Clicking this icon opens two options: VeriFlex zones and Auto Delta. If you enable VeriFlex, you can assign different temperatures to different zones of the thermoblock. A VeriFlex block consists of 6 temperature zones, with each zone covering 2 rows of a 96-well plate. You can adjust temperatures for each zone using the arrows or your keyboard. The maximum temperature difference between zones cannot exceed 5 degrees Celsius. If this limit is exceeded, the software will display an error. When VeriFlex is enabled, a small V icon appears on the corresponding protocol step. The second advanced option is Auto Delta. When enabled, this allows you to apply a gradual change in temperature or time starting from a specific PCR cycle. For example, you can increase the temperature by 0.1 degrees per cycle, starting from a defined cycle number. Another critical parameter is the number of cycles, which defaults to 40. You can adjust this value by clicking directly on it. For more complex workflows, the software also allows you to pause a cycle, which can be useful if you need to add reagents or perform an intervention during the run. In the top right corner, the settings icon allows you to show or hide the protocol legend. The three-dot menu provides additional options, such as saving an image of the run method for documentation purposes, or accessing advanced filter settings. These filter settings control fluorescence detection channels. Be cautious when modifying them, as disabling a channel will prevent data collection for any dye assigned to that channel. You can also disable the heated cover or select a predefined master mix. If you choose a vendor-provided master mix from the list, the software automatically applies the recommended thermal protocol, which can save time. This platform remains fully open, and you are not restricted to predefined master mixes. At any point, you can revert to the original run method if needed. That completes the run method setup. Next, we move to the plate setup tab. This step will be covered in detail in a separate video in this series. If you'd like to follow along as new videos are released, feel free to subscribe to QPCR Academy. Thanks for watching.